Since 1981, with funding from NSF and NASA, astronomer Gary Ferland has used computing to better understand our universe.
In astronomy, we can't go out and do an experiment. We can't go there and measure something directly. So what we have to do is be very clever in figuring out ways to analyze the messages that the stars send us. And the light we receive is difficult to interpret. It's not produced in a simple way. I started in Cambridge developing a computer code that predicted exactly how light would be emitted. So we can look at things here and now very close to us in our galaxy, and we can look at things at the very edge of the universe and look very, very far back in time. But it all comes down to understanding how to interpret the messages we get. And that's what this code I've been working on, Cloudy, does. It was initially funded by NSF in 1980, and they always required that anything that comes out of NSF-supported research be openly available. So Cloudy was actually open source before there was open source software, and it's become to be very, very broadly used across the astronomical community because understanding what the messages are telling us from the stars is so important to everything we do.
Cloudy is one of the most highly cited projects in astronomy. Both the 1998 and 2013 review papers are in the top 1% of astronomy citations in their respective years.
The simple thing is imagine a prism and just passing a light through a prism and you see a rainbow coming out. So we don't call it a rainbow, we call it a spectrum. So spectroscopy is the science of taking that light and then teasing out the information that tells us where it came from. So what we're trying to do in astronomy, take the spectrum, it's something that's called the inverse problem. We know what the answer is. The answer is the spectrum we saw. What we're trying to figure out is what happened out there. What happened out there to make this? So it's like knowing the answer is 42, but what was the question? You know, a lot of different questions have that answer. By using the laws of quantum mechanics, very, very detailed physical laws we know are true, and in large computer simulations, incorporate the complex equations and predict exactly what light will come out. And then using that spectrum, we go back and then we make a what if. What if there is gas near a black hole at this velocity, this close to the black hole? What will its emission look like? And then we can predict that on a regular basis. We do that all the time. The two things I've applied it to mostly are quasars at the very edge of the universe to see what was happening 12 billion years ago, 13 billion years ago. And then here and now, the Orion Nebula, if you think of the constellation Orion, that's the nearest place where we can see birthing happening before our very eyes. We can watch stars being born and solar systems being born. The big thing right now is the Webb Space Telescope called JWST, the James Webb Space Telescope. So I have several grants to prepare Cloudy to interpret the data it will deliver. Webb is going to an extremely high orbit. Webb will be very, very far from the Earth. It will never be visited. And so there's probably going to be something like 5 to 10 years to use it. So we have to really be prepared when it does launch, when the data start coming in, to be able to analyze the data quickly, understand what it's telling us, and then figure out very quickly what should it do next. The unexpected thing in my career is that computers are now dirt cheap, and the computer you can buy for $500 today is vastly more powerful than all the computing in North America when I started out. Cloudy started out as in a language called Fortran. And so I decided 20 years ago that it'd be wrong for the young people to keep using Fortran because that sort of is dinosaur for kind of specific engineering applications, which are not where the jobs are. And we moved over to a language called C and now C++. These are languages which are very familiar to how banks do transactions, how you purchase something on the web. So the skill set that are being taught by working on Cloudy directly transfers over to the skills that are needed to go out and get a job in Fayette County or in Kentucky doing something that's computer related. One of my recent PhDs is now a middle engineer at Google. Others go off into other fields, other professors or something space related. So it's the young people is what has really made it possible because all of this is human effort. Science moves very quickly, and if you talk to young people, if I mention the great people who helped me, the generation before me, that they don't remember who they are. So you don't do it looking for something way in the future. You have to enjoy the present, to be mindful of the moment and happy in the current moment. So that's where I focus.